All right, and I am live again with my homework. Yes, I think it's working. So, yeah, I took a short break. I'm gonna keep working on this. So, um, uh, what can I say? Yeah, it's a time series prediction problem. Um, I This is part two. I think I may have mislabeled the stream to be called part one, but whatever. We're uh, rolling with it. Um, Actually, I might be able to rechange it live. Yeah, there we go. This is part two, and I'm working on this time series prediction problem. I'm at so I don't know. I've over optimistically thought this I could do this in an hour. I'm hoping that it doesn't take me more than like 3 hours. So let's see how far we get. Um, Yeah, this is my steps which we walked through last time. Right now I'm at step two. I'm selecting the input features that I deem purposeful. We're trying to predict the real GDP and the national accounts data from this data set Penworld table, and I have the legend here down here somewhere. Yeah, and we said okay, population must be like relevant for that. Probably employment is relevant. Before I stopped, I I said that employment might be difficult because we're pre-processing it out. I think what I'm going to do actually is I'm going to copy this pre-processing code into here, and then what we're going to do is we're going to not import it. So this way I can mess with this. And in fact, what we realized last time was that I was dropping the ones that had more than 2,500 missing, the columns that had more than 2,500 missing. This is about 12,000 lines on this data set. So what we're going to do is we're going to increase that threshold about like 3,300. I think we'll take employment in, but leave all the other ones out. And maybe before we do that, we'll check what HC is, if that's relevant. But the others, when there's so many data points missing, when half of the data points are missing, I don't think it makes sense to keep it. So yeah, let's see. What is HC? Human Capital Index based on years of schooling and returns to education. Okay, I mean, that does sound interesting. I wonder how the system deals with the time series prediction deals with missing values. It's hard to say, huh? As far as I know, the multi-layer some of the scikit-learn stuff deals gracefully with missing values, and some of it doesn't. So there's no single answer as far as I know. So I don't know how the multi-layer perceptron deals with missings. Caps lock is on. Nothing about missings.
It's 13 hours.
Let's see what happens if I ask Google. Oh yeah, I could try imputing missing values, although in fact my system actually does that before. Oh yeah, that's okay. Maybe I made a mistake here. I drop these columns before I try and impute missing values. That's probably a mistake. I should probably try to impute missings first. So it depends, right? Like if they're missing for entire countries, then I want people to impute them. how did I do it here? Here I just use a interpolate, which is what is that, a standard function in in Python? It's a function of it's a pandas function, I guess. Um, which yeah, it's this one. So this one I think is okay, but probably the scikit-learn one is better. Although maybe it's just about choosing the right option here. But this like multi-iterative computer sounds interesting. That's something that I guess pandas doesn't do. It's not going to yeah, right. And we're dealing with the multi-index because we have the country and the year, and so that is something that only supports this linear method. So yeah, so I'm gonna try and implement this one now. Although this is like kind of dangerous because if I'm trying to predict GDP and then I use GDP to predict like a missing value, that could be problematic. The benefit of using an imputer is that I don't lose the other real data in that time series, which could be valuable. The question is whether I introduce error by doing this. Yeah, it could do. I guess I would have to like try it with and without and see whether my validation tests work better with or without. Yeah, exactly. This is what they do here. So they will impute multiple times and then check whether which imputation method actually makes the most sense on the validation data. Right, so here they use some kind of randomization to run imputation multiple times, which it's not clear whether that actually improves things. I would guess I don't see why this should really improve things. I think you might improve the validation scores, but I don't see why that should improve the outcome if you're using the same imputation method. So that doesn't make sense to me. But yeah, you could run different imputation methods and see which one works better. Okay. This is kind of complicated, so I don't know whether I should maybe just try and skip this step for now and come back to it potentially. Yeah. So, yeah, I think I'm going to do that. So what I'm going to do is I'm just going accept that I'm going to lose a lot of countries by including these variables. And yeah, so what happens is, if I do it like this, for example, or let's say it should be 4,200 to include HC, the human capital index, and then I'm still going to try and interpolate those empty values before I drop the countries, essentially. Actually, I don't drop whole countries, I just drop rows where with missing values. I don't know how that will work if I have then missing values in the time series, like if there's a year missing. That could be a problem that I would have to deal with. But okay, let me run this again. And then let me pull in the data again for pre-processing. And oh yeah, I think actually it was already, this was the unprocessed data. Anyway, it doesn't matter. I'm redoing it. I'm going to delete this step. And I'm going to run this one. And then I'm going to show df here. Let's see. Okay, so let's see how that works. Yes, so we have employment levels, population levels, human capital index levels. Average hours worked. I mean, yeah, that makes sense. Do I still have that one? No, I guess that one got thrown out. I'll just print this when I run this. I'll have to re-pull in the data since I'm destructively editing it. Yeah, okay, so I'm gonna write here somewhere that I'm probably not gonna do this. Just yes. Okay, I need to run this. I didn't print. Oh, oops! I didn't rerun this. I have to import it again. Okay. I think it may still make sense what I'm doing. Part of the fun of doing this as a live stream is that I get to talk to myself out loud, which is the main benefit, really. Yes. Okay, so AVH, okay, that has way too many. 9,000 missing values. That does not make any sense. So that would be like the average working hours for people, so, but that then 3/4 of the years are missing. Doesn't make sense. Okay, so Let's look at the other ones. Does it help to predict exchange rate adjusted, purchasing power adjusted GDP? In a way, yes. It tells us something about how the economy is doing, kind of in international competition. If, for example, real GDP grows faster than this PPP adjusted GDP, that suggests that the country is becoming less competitive on the global marketplace, which should push down GDP growth in the future. Yeah. And I mean, why not? Like, I don't think we can overdo it with features. I mean, we can overdo it with features. The model might just not train very well. Let me leave it out for now. We could add it later. So then there's this section on current price values, so the real consumption of households and governments at current purchasing power parity, the real consumption. I don't see what is here that's not captured by the other stuff, so let's ignore that for now. Real domestic absorption, consumption plus investment. Okay. Yeah, again, I think we're going to ignore the ones that are like related to international exchange rates. For now, I don't think that's that valuable. Expenditures, so this is all PPP level stuff. Yeah, we're going to ignore all of those. I wonder if TFP is available also without that adjustment. Let's see on the second page. Okay, so we have, so TFP at constant national prices. Yeah, so I think we're going to use that. That's total effective productivity. That should influence GDP growth. Capital stock, yes, for sure. Capital services. I don't know exactly what that is, but hold on. That's in, why is that in US dollars? National prices in US dollars? That doesn't make any sense. Oh, I think what I mean is that this has not been purchasing power adjusted. It's real in the sense that it's inflation adjusted, but it's nominal in the sense that it's not purchasing power adjusted. And that's what I mean by national prices, even though it's been converted to the US dollars, so you can do a comparison. But that's just I mean, I don't like purchasing power adjustment, actually. I don't think it's that. It tells you, in some cases, whether imports and exports are difficult. Like, islands tend to have pretty poor purchasing power adjustments. So you notice that if you go to an island, things are expensive. Like, everything is expensive. And that's then reflected in the purchasing power adjustment. If the economy might look like it's pretty good, but then when you purchase power PPP adjusted, then it actually looks like it's not that wealthy. This is why some certain countries can be very poor, even though on paper they might not be that poor. But when you do a PPP adjustment, they become much poorer. But I don't know. I somehow get the sense also that it's doing other things that maybe are not that useful, like ignoring certain kinds of unmeasurable quality differences. So they do try to take quality into account when they do these kinds of adjustments, the same way that they take quality into account when they do inflation adjustments, which is to say you try and measure like certain features of a product. With electronics, this is very easy to do. You can say, well, what's the brightness of a screen? What's the what is the resolution and things like that. You can measure these things, and then you can say, well, if the price, if the features go up and the price goes up, that's not inflation because the product can do more. So what we're looking for is like when you control for all of these factors, how the prices change, and so they can actually, by taking the prices of many different products across many different these feature categories, what you can do is you can like extract which feature is worth how much. So you can say, well, if you go from a full HD screen to a 4K screen, that's worth, I don't know, a 50% increase in price or something like that, and then that allows you to then do the inflation adjustment correctly. And I'm pretty sure they do the same thing when they do PPP adjustment, except that, of course, there's certain things where quality is not very measurable, like I think produce is the best example. Probably you can't really measure the difference between how good is a potato here versus somewhere else. Well, who knows? I mean, you could say this is organic and that one is not organic or whatever. So that can be a quality feature, but organic standards vary widely, and I think it's not a really significant part of the quality. There's many other factors that affect quality of produce. But then you might say, well, produce is not a big factor in economies anyway. That's a very small percentage of GDP. So maybe with the things that matter, it is easy to measure quality. Although I'm not sure. I mean, services are a big part. How do you measure the quality of a service? I don't think you can really. I mean, what's the quality of a hairdresser here versus somewhere? What's the quality of financial services here? Well, people may be willing to pay for a Swiss bank account, but that doesn't necessarily mean that it's high quality. But that's sort of how we define quality, as people are willing to pay more for it for the same features. I'm not really sure. Like, I think there's a lot of things here, for example, that I just feel are much higher quality than in other countries. But most of those things probably aren't really measurable. It would be hard to figure out exactly what is it about. Yeah, a product that you get in the supermarket that makes it higher quality is if bread is just bread. Like, why is the bread here better? Then you do a PPP adjustment. You say, well, bread is too expensive here, so people are actually less rich, or they just buy better quality bread on dimensions that you can't observe. Anyway, that's a rant. We're gonna take. I think we're gonna take all of these. Capital stock. I don't know what capital services are. I'm gonna Google it quickly. How do you write that? Yeah, it's an OECD thing. Okay, so it's something to do with how good capital is at producing growth. So that seems pretty important to put into the model. Okay, we're gonna put these ones in. Basically, I guess all of these ones, which is RNNA, RKNA, RTFPNA. NNA, KNA, TFPNA. Okay, welfare relevant TVP at a constant national. What does that mean? Welfare relevant TVP. I'm going to assume it's important. Share of labor compensation. I'm going to assume that's important. Real internal rate. I'm going to assume that's important. Delta average depreciation rate of stock. I'm going to assume that's important as well. Okay, we're going to take all of these, and I think we're going to ignore everything else because I don't think the other things are that important. Yeah, because the rest is about price levels and stuff, and that's kind of we're measuring real things. Not Not that I fully believe this idea that inflation doesn't matter, that only real prices matter, but we're just gonna try and do this. So RTFP-NA, lab share, internal rate of return, and delta. Okay, I think that's my input features. Okay, so now $8,200 rows. Is that still what I've got? Have I done the pre-processing? No. Okay, wait. No, can't have, because that's weird. But this print is inside here, so oh yeah, it's before I get rid of things. Okay, so yeah, so this has been processed. The data set looks like this now, which is 8,200 rows, 35 columns, and now I can drop everything except for the ones that I want to keep. So let me do that. I think I do it like with something like this, whereby I'm gonna remove this step. Well, let me just comment it out for a sec. Although I don't think I need to rerun this, but just gonna clear the output here. And we're gonna, instead of drop, we're gonna keep. I think that's a function of pandas data frames. This is not alphabetical. Okay. Nothing found. Okay, drop. Are you sure there's no like data frame keep? Oh, I think you just select them directly, right? Yeah, I mean, I think I'm just gonna run this again, where I'm gonna say columns to drop equals something like this, and then not in columns to keep. That's the one I'm not gonna drop. Okay. And then this is my label columns plus you know, I think I'm just gonna delete country code and the currency. What do I need that for? So we have year, country, and then these things. something weird about this? Oh no, it works now. It doesn't work in the text editor, but okay. There is a way to select multiple items, but just manually do it for now. Should have replaced it with commas probably, but okay. No, not like that, like this. Should split this somewhere so I can reasonably see this. Okay. Good. Good. Wait. Oh, I didn't check whether the other ones got deleted or not. So we don't have a labor share, internal rate of return, total effective productivity. That's sort of a problem, actually. We don't have. Oh wait, we also need, of course, to have our output variable, which is this one, and you can put that right at the end. But yeah, I feel like this is kind of problematic. So let's do this again. Okay, R and an A. Oh, we have that one, yeah. What are we missing? IRR, lab share, all the TFP ones. There's a missing 6,000. RKNA, lab share, missing 4,800. So the question is, yeah, what happens when we... I'm going to try that. So let's see. So we're going to keep all of the ones.
1330.
It gives us about half the data set, but who knows? So before, just to kind of check this, before we had 8,200, we're going to have something else now. So to run this again and all of that. Okay, I'm going to have to break for lunch in a second. No, we run this one. 6,400 rows, yeah. I think that interpolation has done nothing, basically. So, yeah. Oh well. I guess it's because mostly it's for a country, like all of the data points are missing. There's not like just in between ones. Or I think if it is for one country, it's like the first 50 years are missing, and then it's okay. Not much you can do about that. So, but this is good. I think this is fine. Now the problem is, and I think this is why we got this exercise, is that when we do scaling, and then we predict something, we need to unscale from the prediction. That's why we need to like use a pipeline. Or another way to another way to think about it is, or another problem. Well, is I don't know if we scale the output variable, maybe, but the problem is also the input variables are scaled, so we just need to rescale them when we do a prediction. Yeah. So that's probably what we need to think about. Yeah, I think I'm going to delete this. I think we're done with that part. And I think we've completed step 2, selecting the input features, and we're now on step 3, which is scaling the features. And for that, definitely we set up a pipeline. And then that pipeline will remember the scaling method, and then when I do a prediction, I'll have the same scaling method. Yeah, I'm gonna take a break for lunch. I'll be back after lunch with part 3. Wish me luck. This hopefully doesn't take all day, but I think it takes me another couple hours. All right, bye bye for now.